So we'll put in the value of the 65 and the 500 into our equation. Henceforth sine 35 degrees is equal to opposite, which is BS, over hypotenuse sine 35 BS, which is the opposite. Sine 35 is equal to the opposite BS over hypotenuse beg your pardon, which is 500. So we are going to cross multiply. Our BS will multiply 1, and it's still BS. Remember, the denominator here is 1. So BS will be equal to 500 sine 35. We'll press on our calculator for the value of 500 sine 35. 500 sine 35, and that will give us 286.79, 2 decimal places, 286.79 kilometers. If we want to find how far north he is, remember that is what we are looking for. How far north is it from the starting point? Calculate correct to the nearest whole number. How far north Salifu is from the starting point? If we want to find out that, we have to this 286 is represented this side, which is the same thing as the QA. So we'll add that one to the 500. So down there, our final answer will be Salifu. We will add the total distance now be 500 plus 286.79, and that will give us, add it on the calculator and tell me, 786.79, 786.79 kilometers. That is the distance here. The distance here. I hope you know that. The distance here. How far north? But we are calculating to correct to the nearest whole number. So we will convert this value to the nearest whole number. Oh, I beg your pardon. It is 0.79, not 0.799. 0.79. So we are converting this to the nearest whole number. That will represent our final answer. So henceforth, therefore, Salifu is 787 kilometers north of his starting point, from his starting point. He's 787 kilometers north from his starting point. Therefore, Salifu is 787 kilometers north from his starting point. Good. So that is the first question. Let's go to another question. The next sub question. It says, calculate how far east Salifu is from his starting point. So this is a starting point. If you want how far east he is, we'll stretch this dimension, then we'll extend the south, and they will meet. Then we'll calculate for this dimension. And remember, this dimension is the same thing as the dimension at the top here. The dimension AS is the same thing as, okay, let me just extend it. Extend it. Extend here, and we extend here. Okay, this is what the question actually is looking for. Let me make everything black. the distance here, but the distance here is the same thing as the distance here. Okay, so this distance can also be partitioned into two. Partition into two, this portion and that portion. This portion is known because we can project a 250 to this place. So let me call this place C. I hope I've used C already. Remember, the points, you must always use capital letters. I can project the 250 here, 250 kilometers. Kilometers is the same thing because this is a rectangle. 90 90 90, it's a rectangle. So what we need to do is to calculate the value of this line. The value of this line, we can use this triangle and this angle to calculate the value of this line, which is the same as our CS. We can also use this triangle, which is also a right angle triangle, using the 55 degrees and calculate the value of this line direct. And I'm going to use this triangle this time around, this one, and this is our reference angle. This is the opposite and this is the hypotenuse. So we are still going to use sine. The formula is still the same. Sine theta we got the opposite over hypotenuse. So let's go. This is a solution for the second question. II. Is it really the second question that we are supposed to solve? Let me check. I think that will be the third question. II. Good. And then label this one. This one's supposed to be the second question. I. Good. We are now coming to look at how to find out how far east is set, as I said, and we are still using the same sign, this triangle. So I'm looking for the opposite, and then I know the hypotenuse. The opposite is CS. Let me bring this as somewhere closer to the point. So CS is the opposite. Our hypotenuse is still 500, and my angle now is 55 degrees. So sine 55 degrees is equal to CS over 500. This is over 1, so we'll do another cross multiplication. So when we multiply CS by 1, we still have CS. And 500 will multiply sine 55 degrees, which is still the same thing, which we will press on the calculator for the value of sine 65 degrees, and the value of sine 65 degrees, 500 sine 55 degrees, sorry, is 409.58, 2 decimal place, kilometers. Then we know that this is 409.58. Let me copy and place it here. Where we are looking for the full distance, how far east this line, which is the same thing as this line. So we need to just add the 250 to the answer we just got. So this would be 250 plus 409.58, and we are going to get 659.58, 659.58, 659.58 kilometers. Then add the kilometers. It's very, very important. Sorry, 250 plus 409.58 0.58 give us 659.58 kilometers. Okay, so that is that. So Salifu, we can also approximate it. The question didn't ask us to approximate. If you go into your textbook, it has been approximated, so it was intended that it should be approximated. So the approximate value to the nearest whole number or to the nearest kilometer, we will say Salifu is 660 kilometers as nearest kilometer east from his starting point. The last question, question 4. The question says we should calculate the bearing of Salifu's final position from his starting point. So in that instance, we'll draw a line from the final position to the starting point. So what the question is requiring us to calculate for is this particular angle. This particular angle. Remember that we know the full distance here. So we are come to use this right angle triangle to calculate for the angle here. Okay. Good. Remember that this 500, not this 500 confuse you. Let me remove it from this position. The 500 here is for this distance, not this line. It was there before I drew the line. So that is it. We're going to calculate for the bearing from here to here. Let's now put a variable there. Let's see. Let's call it x degrees. Calculate for that bearing, x degrees. X degrees. Sorry for the noise. I just want to finish this tutorial. There's no noise all over the background, but today I couldn't get a conducive atmosphere to do the recording. Forget about the noise from the background and concentrate. I have one more question to solve and I'll leave you. I am looking for this angle. I know this side, this side AS, the full length here, that is my AS, 659.58. Then AP 786.79. This is the opposite, is the adjacent. It means we are using tan. Tan. So our tan x will be equal to the opposite, which is the value here, the sum of these two numbers, over adjacent AP. We had it here, AP. Remember, do not use the approximated values. Do not use the approximated value, other than that you not get correct results. Always use, don't use the, when I say approximated value, I mean the numbers you have rounded to the nearest whole numbers. Do not use those ones. Use the decimal values up to 2 decimal places. Okay, it's better. Okay, now let's look at how we are going to calculate for our x. The tan will have to cross the equal sign, as you know. So our x will be equal to tan inverse of this fraction. So you press on your calculator, tan inverse of this fraction. And when you press, tan inverse of the fraction is 39 point. So our x is equal to 39.97 degrees. But we can't leave the answer in this form because this is bearing. It must be rounded to the whole number. In bearings, angles must be rounded to the nearest whole number. So hence Salifus final destination is at the bearing of 040 degrees. Remember, this is a 3-gauge bearing, so we proceed. We round this one to 40, but it must be preceded with 040 degrees from the starting, or from his starting point. From his starting point. We'll look at the last question. That will be a past question. Solve one past question. Then you try your take-home assignment. Good.